Thanks, everyone. Great to be here with you all today. My name is Matthew Formica. I run Edge Marketing at Intel, and I'm glad to spend this time with you. Thanks for turning out. Hopefully you all saw our announcements yesterday, our Intel Core Ultra Series 3 based on our new 18A process technology launched. It's a great AI PC product. It's also a great Edge product. We'll talk about that a little bit today. So a lot of ink has been spilled about the Edge AI. There's a lot of companies that are saying that they're excited about this space. Some of them are very new to the space. Intel's not new to this space. We've actually been selling products into the, depending on what you call it, IoT, embedded, edge market for over 40 years. We've sold over 200 million processors into the edge in the last 10 years alone. And we have over 4,000 ecosystem partners. So we are one of the most established players in this market. We have a very deep set of partnerships around the world, and we know this market really well, what it needs. But there's always a massive amount of innovation and transformation happening. And I want to talk to you specifically about what we're seeing in the Edge AI space here today. So AI at the edge doesn't look like AI in other parts of the market. If you think about what's cutting edge in AI today in the data center or the enterprise, you're probably thinking Gen AI. You're thinking chatbots, you're thinking LLMs. The most common format for AI data at the edge is actually video data. It's vision, it's images. It's pretty standard and common. The most common sensor at the edge is to point a camera at something. And when you do that, you can get all sorts of rich information that allows you to optimize processes, reduce costs, and gain economies of scale, and even enable use cases that wouldn't be possible without this technology. And so we've seen this over the last decade plus, where innovations around defect detection on assembly lines, quality management in restaurants and quick serve ordering, medical imaging and the ability to optimize how X-rays, CAT scans, CT scans work, all keep advancing. And we now see a new innovation wave that has just begun, just in the last year or so, really, around Gen AI finally coming from the data center and the enterprise to the edge. And when it does so, it looks a little bit different at the edge than it did in the data center and the enterprise. And we're going to talk about that. So Vision AI, this has been the Edge AI transformational path for the last 10 years or so, as I mentioned. If you think about the history of computer vision models, you think about ResNet 50, you think about MobileNet, you think of the rise of YOLO. These are all computer vision models that are really efficient. Some of the flavors get down to 8 or 9 million parameters in size. A lot of them are in the 50 million and below class of models. And those models increasingly have been able to run really efficiently on traditional Intel Core-based hardware, either on the CPU or the built-in integrated GPU that we have. And so you've seen a ton of use cases now getting fairly mature. One of the most mature markets, for example, is smart cities and emergency management, where license plate detection is highly reliable and accurate. If you're anything like me, you might have gotten a ticket in the mail based on a camera that saw you not stopping on a right turn and sent you a ticket based on your license plate. That's happened to me. Maybe it's happened to you. And that's all based on this sort of computer vision technology. Relatively mature, although still a lot of areas of the market where it's advancing in deployment. So wouldn't say we're done that transformation by any stretch of the imagination, but we understand that technology. What's new is really agentic and physical AI coming to the edge. And the models aren't LLMs, large language models like you would think of. Instead, they're what we call VLMs, vision language models, or VLAs, vision language action models, typical in robotics. And these models combine traditional computer vision, which some of the transformer and language architectures from LLMs, into a new class of models. And they do so not at 70 billion parameters, but at 7 billion parameters and below, typically. And so these models are compact for Gen AI. They can run efficiently at the edge if you have the right hardware. And they are still, however, much larger and more compute intensive than the traditional computer vision models that came before. So why would you do this? Well, the reason you'd want to do this is because these new models, by nature of their increased complexity and size, are able to have much more context understanding of what's actually happening in the video. It's not only identifying objects in the video, it can actually tell you the scene, what's going on. You can do searches through video and vision data. You can compare and contrast. In the areas of VLA models and robotics, it actually can gain a better understanding of the scene and the series of motions and steps a robot needs to take to actually interoperate with that scene. And so these models have much greater contextual understanding and ability to operate in the video data. They're also more resilient to change. And this is really important when you want to actually deploy models. If you've ever tried to build something computer vision at the edge in a POC and it works in the POC, and then you deploy it and you find that model drift and a variety of other real world issues prevent you from actually having good accuracy on that model, you know the importance of resilience of model. And these new models, these VLM models, are far more resilient. And so just one example, order accuracy tracking in quick serve retail. This is a use case that's not new. Computer vision, traditional computer vision has been applied to this for a while. If you order something to be delivered to you, typically it's becoming increasingly common for there to be a camera pointed at whoever's assembling your order to make sure that everything makes it into the order. It's expensive for them to have to resend something or fix an order, so they'd rather make sure everything got in there the first time. The challenge with those traditional computer vision models is that frequently the packaging changes, right? You might have a can of soda that has different advertising, different coloring on it. You might have precisely what they ordered be more custom, be more complex, and traditional computer vision models really struggle to keep up with those changes. Whereas these new VLM models have a much deeper understanding of what is it we're looking at. We're looking at a can of soda. We don't really care what the labeling on it is. We can identify what words are on it, what brand it is, what it is. And so that increased resilience means that these models are actually more deployable at scale in the real world. So how are they being used? Well, if you believe all the hype, you'd think that humanoids as house help is right around the corner. But if you've actually gone up and explored a lot of these humanoid robot demos and some of the autonomous agent demos, you've seen two things, probably. You've probably seen the incredible innovation that's happening at that cutting edge of technology that's on the cusp of being ready for deployment, in some cases even is being deployed. And you also start to see how far they still have to go. There's a lot of difficulty in getting robotics to work well in the real world. There's a training data gap around robotics that's still not fully solved in the industry. And so this is where a lot of the hype is, and it's true, there's a lot of amazing innovation that Intel and others are participating in this space, but where we expect there to be more rapid deployment sooner is in actually a lot of other cases, more like the order management scenario I was telling you about, where use cases that may already have come into being as traditional computer vision are now being upgraded with these new models and augmented with new capabilities that weren't possible before. So I'll give you one example, which is in the area of smart cities. Cities for a while have used computer vision, as I mentioned, to do basic traffic management, to identify wrong-way drivers, to handle a variety of emergency services. What they haven't done is integrated all those capabilities together into a system that can dynamically take different data feeds and agentically figure out, is what's happening on this camera really a crisis, or is it just something that will resolve itself? Do we need to send all forms of emergency management services to the scene, or do we send just fire, or just an ambulance, or maybe just a police car? Like what's actually needed on the scene? And cities can become more efficient if they don't have to send everything to everything. And so we're doing a variety of pilots here in the US, specifically with cities around integrating all these using agentic and physical AI, these new VLM models, and simplifying the work of the operator to understand where do we really need to send services in the city. That actually improves the efficiency of the services the city's already paying for and delivers a better SLA for the residents of that city. So there's a lot of really exciting use cases for these new VLM and VLA technologies. Then when we think about actually deploying these, if you're coming from an enterprise or data center space, these are probably some of the challenges that you've had to work through. You've had to think through, what are we really going to automate? Where are we going to keep humans in the loop? If you're managing your own data center, you're thinking about how do we deal with the power of that? How do we run the complex models? Do we have the right hardware? Cooling, scaling, all of those issues. Or if you've outsource that to a cloud service provider, then you're trying to manage your cloud service provider costs, hence the rise of hybrid AI. You're dealing with models that are very, very large and trying to figure out how to manage what they can process. And you're dealing with challenges to adoption that we probably all know, data privacy, latency, et cetera. And you may wonder how many of these same problem statements or the same solutions apply to the edge. Can you really do agentic AI at the edge? And the answer is yes, because we've been working with a variety of customers to do it. But there really is a difference. There's a variety of things you have to think about when you're going to deploy at the edge that you typically don't have to think about in the enterprise or the data center. And these are not new, but they're kind of dialed up when it comes to agentic and physical AI. For one, you have really low latency requirements, typically at the edge. It's pretty standard for the edge to have latency requirements under 50 milliseconds for inferencing. In many real-time cases, it's less than 15 milliseconds. In some robotics functions, it's actually less than 1 millisecond. And so you have a very narrow window of time to do computing, and you need a light enough weight model and a powerful enough processor to be able to do the work necessary in that amount of time. But you also need determinism when you do that. You can't wonder if the processor will have the right information in cache, if it's going to have a CPU available, if it will be able to context switch from something else it's doing. And so you need determinism built into the processor, specifically to handle a quality SLA of when processing will actually happen. You also have to pay attention to the environment that you're deploying into. It's pretty common to need ruggedized hardware that isn't going to run on the standard 4 to 8 hours a day for a couple of years, but may need to run 24/7 for 10 years. And so you need hardware that is certified to run that amount, that length of time. You need silicon availability for 10 years. If you've taken the effort to build and deploy something at scale in the real world, rolling more truck to deploy more of it is hard. You really want it to just keep working. And that means you might even need extended temperature support. And Intel processor support down from -40 to 100 degrees Celsius or more if you buy the right SKUs of our processors. And so these are all things that you have to work through at the edge to go from, that's cool, it works in the lab, to can we actually deploy this at scale in the real world? And so this is why I'm really excited to be a part of our Intel Core Ultra Series 3 launch that we did yesterday. You've probably read about it online. This product, previously codenamed Panther Lake, delivers against all the things I was just talking about. It delivers up to 180 TOPS of AI compute with really good memory bandwidth. This is 1.8 times as much TOPS as our prior gen product, and is effectively, with all of the integrated AI acceleration built in, like having a discrete accelerator of AI built right into the SoC. It has deterministic performance, which means we've built in something we call time-coordinated computing, so that the processor gives you that guaranteed SLA of how long it will take, and it is doing work behind the scenes to make sure that it can deliver to that SLA. It's making sure certain data is not removed from the cache. It's making sure certain cores are kept warm. It is doing a bunch of things behind the scenes so that you can be sure that you will get the performance when you need it, exactly how much you need. This is our first Core Ultra processor that has full industrial use conditions and extended temp SKUs available. And so we're building this product to last for the next 10 years in the market at the edge, where it will continue to deliver great results in a wide variety of rugged conditions. And from an enablement and software perspective, we have two things. You may have heard of our OpenVINO software toolkit. This is our widely scaled inferencing library for Core and Core Ultra and Atom and Xeon-based processors at the edge, and it enables really fast inferencing on Intel-based hardware. We build that in as a foundation layer to our OpenEdge platform, which is an open source project where we assemble industry-specific edge AI suites for manufacturing, robotics, retail, education, and more, to enable you to very quickly get best performance on our processors at the edge. So when you take our long industry expertise at the edge and you realize what the requirements are of the edge, you start to see that purely winning on how much power can you throw at a processor and run it in a lab is not really the right way to think about it. You need to take the right processor at the right latency and compare it against other equivalents at the edge. And when we do that, we believe we have a leading product for the market. For example, here we're comparing against the NVIDIA Jetson Orin AGX, where we have higher LLM performance, better performance per watt per dollar on end-to-end video analytics, higher image classification, and we even have higher vision language action model performance due to our greater throughput through the overall processor. And this really comes down to the fact that TOPS in a vacuum is not all that matters when it comes to real-world AI performance. Memory bandwidth matters. Video decode matters. If you're doing a lot of work primarily with vision and video data, then you want to make sure there's no bottlenecks getting that video data decoded and to the AI engine in your processor. And so you need a balanced product that can hit all of these, and when you do that, you get this kind of performance. The integrated AI acceleration in this product, especially the integrated GPU, is so powerful that for the first time, it's actually really capable of doing light fine-tuning training workloads as well, something you would have never expected could be in a PC-style processor. And so where we're seeing this play out is in things like industrial PCs in defect detection, where often you'll be doing inferencing of defects on an assembly line. You'll have a camera pointed at the assembly, products coming off. You'll be doing inferencing to make sure those products are built correctly. And periodically, you'll want to go update your model with new information about what those defects are actually looking like. You want to fine-tune your model. And now, the traditional way to do this is to get something, a discrete GPU, maybe, a product from one of our competitors, and do some fine-tuning on that product. But now with Intel Core Ultra Series 3, you're able to actually do that fine-tuning at almost the same performance right on that industrial PC, but at a fraction of the cost, and then immediately put the model back into production. It's basically a closed-loop automation system. We're doing pilots with some of our customers on this right now. So this is a really exciting innovation where we've finally cleared the hurdle of being able to do that fine-tuning right on the SoC without needing a discrete GPU at all. And you save a lot of money and power over time doing so. This product is a very balanced product, as I mentioned before, and it has all the different kinds of AI engines that are necessary. The VLM and VLA model landscape is changing super fast. Every month, we've actually been plotting how many new models are invented out on, say, Hugging Face or other platforms every month, and the number keeps going up. And the architectures are changing. There's a ton of innovation in this space, which means we don't know the exact final destination of the right mix of compute. And so the best approach is not to bottleneck yourself by picking one thing that's going to perhaps prove to be wrong, but to have the right balanced architecture that can handle everything. And we have that here in Intel Core Ultra Series 3. And so here are some results comparing us versus leading products from AMD and Qualcomm, where our NPU is actually superior performance in this product. Our GPU is superior performance. In many cases, our competition can't even run the benchmark. And so we believe that this is the right product for the edge and is a leadership product. Now, it wouldn't be enough, again, to put a product out without thinking about how enablement actually happens at the edge. And our partners need a variety of hardware and software, dev kits, et cetera, to actually do this work. And so we're doing that specifically for robotics. So I have here a dev kit that we've built with partners and a robotics reference board, basically a module that you can slip in for robotics. Comes with Panther Lake, and these will be available later this quarter into early Q2 from a variety of partners. And these products can help developers really get going quickly, especially in robotics. Obviously, there are a wide variety of use cases I've been talking about here today, but whether you're a software developer, an ISV, who wants something that has all the right I/O for robotics, or whether you're trying to integrate something more efficiently into your actual robot that you're building, we'll have a product for you. And we cover the software side as well. I mentioned our new robotics AI suite. We've been doing robotics for a long time. A lot of traditional robots, stationary arm style in manufacturing, are based on Intel processors to do the control function in those. And so we have a lot of history in the software space in robotics, but it was honestly scattered across a variety of different open source projects and initiatives. We've now consolidated that all together. We've built in a lot of new vision AI capabilities with support for new models like Pi Zero and ACT in the VLA space. And this enables developers to very quickly get great performance doing robotics on Intel silicon. And so, coming back to where we started, we've been in the edge space for a long time. Traditional computer vision has been leading the innovation charge for the last 10 years. And we now have this new wave of agentic and physical AI that is adding a new layer of innovation and transformation, much of it not fully even deployed yet. We're on the cusp of that now. And new products like our Intel Core Ultra Series 3 will help enable all of those exciting use cases. So with that, I want to invite a few special guests up on stage to join me, where we'll discuss for a little bit what they're seeing in the markets. So folks, come on up. Thanks for joining today. Let's have a seat. We've got a few special guests. We'll give you each a minute just to talk about your respective companies. David, I'll start with you. Why don't you introduce yourself?
Yeah, sure. Thank you, Matthew. First of all, thanks for having us here on the panel. It's a pleasure to be here with you.
Yeah.
I work for OnLogic, and we are an industrial edge AI compute company. And we build ruggedized computers, industrial PCs, servers, and panels, specifically for AI edge use cases. We're based out of Burlington, Vermont, here in the US, and we have full assembly capability for devices that we want to build here in the United States, as well as we have a full assembly capability in the Netherlands to support that market.
Awesome.
Yeah.
Great to have you with us. Thank you. Ivy, you're in the software space. Why don't you introduce yourself and your company?
Yeah, certainly. Thanks for having us here. And I want to give a little history about WildFaces. It's actually a spin-off from a 25-year-old AI company who has done a lot of the smart city, 75 smart city in 70 countries. And I think it's the reason that we spin it off, WildFaces, is because we want to extend our AI capability, multi-sensory AI capability that can, we make use of the video, sound, and smell, in the on-the-move space, like working with the robots, walking robots, flying drones, and moving IoT, and etc.
Thank you, Ivy, for being with us and for representing ISVs up here. Keith, you're CEO of a robotics company. let's watch a video about it, and then you can tell us about it.
Hey there, meet the new Intel Core Ultra Processor Series 3, pushing the boundaries of what's possible at the edge.
Just a raise of hands, how many coffee drinkers here? Yay, you are all my customers. So that's Ella. She's our friendly robot barista. And that was taken in Tokyo train station in Japan. So I'm Keith from Sensory AI. I'm from Singapore. And over the last couple of years, I've been building robots and taking them out of the factory into our daily lives. Places like convention centers, hospitals, maybe a cafe near you soon. So we are in the intersection of robotics, edge compute, and AI. And we've been working with Intel on edge architecture to deploy robotics in the real world. So I'm here going to share with you my experience. Thanks.
Great. Thanks, Keith. Thank you all for joining. You heard me talk a little bit about the waves of transformation in edge AI and what we've been seeing the last 10 years, and then this latest round of innovation. I'd love for you each to talk a little bit about what your customers are telling you, how that's affecting your roadmaps and the features you're offering. David, let's start with you.
Sure. I think when we think about this, thematically, it's almost the shift from passive detection from computer vision to active reasoning and decision-making at the endpoint. So thematically, we're seeing more and more of our customers taking their AI workloads into more of a decisioning process. What that means for us at OnLogic is traditionally we viewed our endpoint devices very much as gateways, right? We aggregate data points, feed it into the cloud, some decisions can be taken. More and more, we're seeing the need to turn these into agentic management devices, if you think about it like that. So much higher powered devices, while at the same time, we have to continue to support our customers' needs for having the right form factors, the right scalability in terms of wide temperature ranges, shock and vibration, and highly customizable and configurable devices. So I think that's kind of where we're looking at things, as being able to produce much more higher powered devices that can support all of these end use cases, while still maintaining that flexibility of a highly customizable, highly configurable device that fits within the needs of industrial compute at the edge.
That makes a lot of sense. And Ivy, what are your customers telling you they want to do with that compute?
Yes, as a software, AI software company, and we are seeing through these 25 years of AI journey, we are seeing more and more customers. They are, because the scale, the project scale has become larger and larger, and they are, demanding more to put the AI on the edge. So that they have fast response and they have the real-time analytics going on. So actually, Edge is able to help us a lot in this space. And we have also advanced ourselves from, used to do the vision-based AI, and now we are into multi-modal AI that utilizing multi-sensory. We see, we hear, we also smell, to come up a better judgment, to better emulate complex human intelligence.
That's awesome. And how is this wave of innovation affecting how you think about robotics?
Well,
Keith?
within the food service industry, there's a huge, massive demand for it. Robotics to come in and support humans, and in the workspace, and building more compliant robots that adapt to very, very messy environments. I think that's going to be a very exciting, next step for us.
Yeah, and you need the contextual understanding of these more complex models in order to even be able to operate in that environment.
Exactly like what you said earlier, computer vision is classical. Today we're talking about perception, understanding about a contextual understanding of the world, right, and manipulate the robots and be adaptive in that environment. I think that's where it's going to be.
Yeah. So let's go a little deeper into what you're seeing with your customers. David, I'm sure you've seen a lot of POCs and they don't all make it into production. What are you seeing are the real use cases that make it over the hump, so to speak?
Yeah, there's a couple that we've seen over the past 6 to 9 months that are pretty cool. The first one I can think of is in what used to be a traditional defect detection. You referenced it earlier, using computer vision to detect. Changing those models, and we've seen some customers moving into thermal detection solutions. So building out models that are different than pure video capture, improving the defect detection capabilities, but also being able to find the problems before they exist. So you're almost getting ahead of things in more of a predictive space than a reactive space. The second thing that we're seeing a lot of is in the warehouse and logistics world, where from an inventory management perspective, classically you would use computer vision for inventory tracing and tracking. Now you're starting to see more and more autonomous robotics coming into the warehousing and the logistics and supply chain management space. So these huge transitions, again, from classical computer vision models to much more compute intensive, much more predictive types of use cases that we're seeing.
That's really interesting. And so what you're highlighting there, again, reinforces this point that sometimes it's taking what was already sort of partially getting deployed and working and taking it to a whole new level.
Absolutely, absolutely.
Center of gravity of some of these use cases now fully able to be deployed at scale.
It's not just taking what we used to do before and improving it, but it's being able to take what we used to do, improving it, and then driving it at scale is, I think, what we're really trying to drive right now.
Ivy, what are a few use case examples specifically that your customers are asking you for?
Yes, I want to carry on what David has mentioned. I'd like to talk a little more about our predictive maintenance. Because we can see crack lines, we can hear vibration and from the engine, and we can also smell, from any complex chemicals that might indicate a leakage. So by combining, all these sensory, we'll be able to come up with a better judgment on what's going on in our surroundings, such as in a smart building, which we can get access all the time, or outdoor environment, for a facility, for a, utility, like that, right? So, by doing that, we actually making use of, we can do the real-time analysis of, from the multi-source, from historic data, compare with the most current data, in order to derive, the new data to allow us, to tell, when these machines need maintenance, when you need repair. So because we always indicate a new, health index, to streamline the inspection process, because nowadays we tend to send in inspectors without knowing whether the machine is breaking down. But with our integrated analytics going on, and that gives you the real-time information, so you can send in when the machine is breaking down, to fix it just before that.
That's great. Multimodal really is the future in that respect. Keith, we've seen robotics for a long time. They were traditionally very deterministic. How are you seeing the architecture of what it even means to build a robot starting to shift?
So robotics are not new. I think, over 40 years. But for many years, they've been constrained within very structured environments in the factory. That's where the robots thrive, being very, very fast in speed and safety. But that has been, putting that into a messy world that we live in, deterministic robot processes are going to fail. It's going to break. And in the last couple of years, we've seen perception-based, like VLAs, where it's the inverse kinematics are really controlled by perception. And that means it's able to react in real time, near real time, and adapting to the changing environments that the messy world we live in requires. And that, to me, was the biggest change, perception. And that requires a lot of compute on the edge, and moving a lot from the cloud down to the edge device, where latency is, you have no chance on with robotics, right? You've got to be really time to first token, even on the LLM layer, right? You don't need, you can't have that latency. So that's where I think there's going to be a massive uptick and build for physical AI in the next generation. Yeah,
makes sense. Now, to deliver all of this, certainly your customers aren't coming to you saying what computing platform you're using, but it is something you all have to think about. So Ivy, I'll start with you. What does this mean for the compute requirements that you need, and what do you think of Intel Core Ultra Series 3?
Right. As we know, customers always expect more, from us, right? So, and customers' concern, because we deal with end user, and their concern from us as a software company, AI software company, they actually expect our AI will solve their pain point. Okay, so they are more looking at the application level. So what we are delivering I think we are very carefully select what hardware that can give us the real-time, detection, that can give us the, that can respond within milliseconds, like that. So we have been working closely with Intel. We actually married to Intel, okay, so for the past 25 years. So we start with Intel's Atom, and that already give us what we need, and then from the Atom to, because it's low power, as I mentioned before, like more and more customers, they are looking, for the edge solution. So we have been using Atom, and we're quite happy with Atom, and then later on we moved into i5, i7, like that, right? But ultimately, I think we are very hopeful that Intel Core Ultra Series 3 will help us a little more. For example, if we are flying a drone into a confined space, the drone is carrying all the sensors, so in a confined space, so we have to make sure that there's no latency. So I think in old days, maybe the drone can only fly a short distance, and now we are expecting that can fly a much extra miles, like that, right? And more importantly, because of our intuitive AI, we have our own quick training engines that do not require power-hungry, discrete GPU cards, that actually save 16 times of the carbon footprint, with these with Intel embedded GPU and other hardware components. So I think it gives us the right platform to work with.
That's great. Looking forward to continuing to collaborating with you for the next 25 years. David, what are you seeing?
Yeah, I see a continuation from a hardware perspective. And when we think about our hardware, we think about it in kind of three pieces. The first is absolutely fantastic ruggedized hardware that meet all of the shock and vibration, all the temperature ranges, all the mil specs for what we need for to satisfy our customers. The second is reliability and resilience. And I think you touched on that a little bit in your preamble, but specifically, what is that long-term solution that customers can count on year after year after year, that the hardware isn't going to fail? And then finally, we think about things in terms of right sizing exactly what our customers need. And the way we solve that is by having a highly configurable, highly customizable capability so that we can meet our customers' needs. Where Intel fits into that is exquisite, right? With the integrated NPUs, with the integrated graphics and compute capability, it allows us to meet a lot of our form factor requirements, as well as the scalability for these edge devices, while being able to design on singular platforms.
That's great. The wide variety of form factors. We track over 100 discrete form factors at the edge. And we have to do that to support partners and customers.
Yeah, and I think that's a big piece where a lot of folks that are coming from more of an enterprise setting, whether it's a data center or an enterprise client setting, and start to move out to the edge, they don't realize how fragmented the market is, and highly differentiated the form factors are, and the device types are. And again, we put a lot of time and energy into this, and making sure we're building the right size device, the right type of device, with the right types and levels of compute to meet the end customer's needs.
Yeah, and speaking of interesting form factors, robotics is maybe an extreme case of that. What does this platform mean for you?
For us, it's also the BOM cost. Deploying them, the clients are retail operators. The cost of the compute makes it a lot, in terms of deployability. And also the form factor. We believe that a lot of the models are going to be pre-trained, and then it's really local inferencing that we need. So I'm very excited with the new 18A architecture, with the integrated GPUs and NPUs. We are actually able to deploy them on the edge. There's no need for a discrete GPU anymore, and that saves money and thermal headroom as well, and no throttling. This is people don't talk about this, but when it gets hot, all right, and you have a deterministic, I think the Intel architecture has a way where the SLAs are guaranteed.
Yes.
So this is something that is so crucial. Thermal headroom,
Which doesn't show up in a marketing slogan.
No, it doesn't.
Now we have thermal headroom is not a marketing slogan, but it
and
matters
when
for
things
real
start
deployments.
throttling because it's too hot, right? That's where things break. We face failures in the real world, deploying it out there, and customers need that consistency, that the reliability, and having that 5 years, 10 years of the silicon, right? That gives us that kind of, promise, right? Because my machines are depreciating over 5 years, we need that reliability. So these are the concerns for us on a hardware perspective on deployments.
That's great. And as one last question, if we just look forward a year from now, if you were to future cast, imagine we're sitting up here at CES a year from now, what would you predict was one change that might happen, that you might see from either the industry or from the AI space? Give me a prediction.
Ella's going to serve everyone here coffee, great coffee. I'll start since I think you're going to see a lot of compute moving onto the edge device. That's first. Cloud's going to be more of a control plane managing distributed machines. That's from my perspective. A lot of that decision making is going to be done on the edge device. That requires a lot of compute power, right? And this is where I think that's going to then enable a lot of robots to be very reactive, even adaptive to environments. And that's where you see physical AI really taking shape.
Yeah, maybe I want to maybe go into that because mine's very, very similar. I see this transition away again from kind of these gateway ingest engines to being these AI agentic orchestration devices at the edge, right? They are going to have to take on much more compute capability. There's not going to be time or TCO to call back to the cloud. It's going to have to move out to the edge. And I think selfishly, Matthew, I think I would like to see one of our signature orange devices sitting in every manufacturing and warehouse on Earth. If you could help me make that happen, that'd be great.
Let's work together on it. Yeah. And Ivy, you'll get the last word. What do you predict?
Yes, I think we won't be sitting here next year. We will be lying flat on the beach, remotely controlling our robots to be talking on behalf of us, right? So I think that would be something that I'm hoping we will see that very soon. But from the software, AI software perspective, and I can see that the customer is expecting lower total cost of ownership, which I'm relying on Intel to give us. And from the software perspective, I think they will demand more accuracy in order to achieve, autonomous. Okay, so this is what we are hoping. Of course, we will continue to advance our technology to cover more industry use cases and some exciting use cases, etc.
Great.
I want to add one more. It's about data. So we have a lot of human-robot interaction data that's collected on the edge. And with deployments across different geographies, there's this thing about data governance and sovereignty. And I think that's going to help a lot where your data sits on the edge, and that will help with your deployments as well. So, yeah.
Great predictions all. Thank you for your time. Thank you all for your time with us today. Have a great rest of your day.
Thank you, Matthew.
Thank you.